folks, welcome to
Vector Calculus.
Alright folks, today we're looking at an example of how to find the focus of a parabola. Let's go ahead and write it down. We have this parabola, we want to find its focus. Let me remind you what the focus of a parabola looks like. If you have a parabola like this, the focus is going to be right here. It's kind of like a ball in the center of the parabola. Now, how does our parabola actually look like? Well, to answer that question, we look at two different things. Number one, what's the equation of a standard parabola? Well, the equation is going to be given by the following formula. We have 4p times y minus k is equal to x minus h squared. That's the equation of a regular parabola. Okay, and that parabola is going to look like this, like a happy face. But now notice, even though the square is on the x term, notice that this is a minus sign. That's going to take this parabola, flip it like this, so we're going to have kind of a frowny face. So our focus is going to be right here. So that means that the equation, or rather the formula for our vertex, is h comma k. If you want to know how I got that, check out the last lecture. And the formula for our focus is simply going to be whatever k is, but shifted down by p units, right? Okay, now our goal is to get the equation of the parabola from this form to this form. So if we can get from here to here, we're basically done. So let's go ahead and do that. Okay, I'm gonna do it in light green. So first and foremost, I'm gonna complete the square over here. I'm gonna take you through every step. So y is equal to half x minus half x squared. First thing we're gonna do, multiply both sides by -2. So if I take my orange marker, multiply both sides by -2, what will I get? Well, on the left hand side, I'll obviously get minus 2y. What do I get on the right hand side? Minus 2 times half is going to give us minus x. Minus x times 2 is going to give us positive 2x. And finally, minus half x squared times minus 2 is going to give us positive x squared. So if we just rearrange the term, we're going to see that we're really close. Sorry, I meant 1 right here. I don't know why I wrote a minus half x. So now if you look at this, we're really close to a binomial square. All we need to do is add 2 to both sides. Hopefully you see why. If you don't, just wait a few seconds and wait for the magic to happen. So on the left hand side, I'm going to end up with minus 2y plus 2. On the right hand side, hopefully everyone can see that. If not, let's put down the screen. So on the left hand side, as you can see, I just got minus 2y plus 2. And on the right hand side, what am I going to get? I'm going to get x squared plus 2x plus 1. And of course, hopefully everyone recognizes that. That's a binomial square, ladies and gentlemen. So on the left hand side, we have minus 2y plus 2. On the right hand side, we just have x plus 1 whole squared. Just like that. Now we're almost close, very close to this form, but let's factor out this minus 2. So we have minus 2 times y minus 1 is equal to x plus 1 whole squared. And that, ladies and gentlemen, is the form we want. Okay, so let's write the form we desired in the beginning. That's 4p times y minus k is equal to x minus h squared. That's the form we wanted, and this is the form we got. So now we're very close to finding the focus of the parabola. So let me just go ahead and erase all of that. So what am I going to end up on the left hand side? Well, let's first make some analogies. This 4p is equal to this minus 2, right? Hopefully you see that. This minus k is equal to this minus 1. Hopefully you see that. This positive 1 is equal to this negative h. Hopefully you see that. So we can set them equal to each other right over here. So I can write 4p is equal to minus 2. 4p is going to be equal to my minus 2. And you can probably do this in your head, but just for the sake of it, I'm going to do the math in front of the audience. So 4p is equal to minus 2. What's p going to be? Well, p is simply going to be minus half, right? P is equal to minus 1 over 2. What about minus k equals minus 1? So I'll color code it as much as I have to. So minus k is equal to minus 1. And of course, that means that k is going to be none other than positive 1, right? K is going to be none other than positive 1. And if I know that k is positive 1, I can finally find out what my h value is going to be, what the x coordinate of my vertex is going to be. Okay, so let me just go ahead and write that down. So my x coordinate of my vertex minus h is equal to positive 1. So let's go ahead and write that down. Minus h is equal to positive 1. Hopefully I made no arithmetic mistakes right there. So if I just go ahead and solve for h, I find that h is none other than negative 1. So h is none other than negative 1. Okay, now I know my p, k, h values. I'm ready to find my vertex and my focus. So let's go ahead and write these down. I know that my vertex, the vertex of my parabola, is going to be in the form of h comma k. And of course, what is my h? My h is going to be minus 1. What is my k? My k is going to be positive 1. And now I know my vertex, I can finally find what my focus is going to be, right? So I know this is my vertex, minus 1 comma 1. Let's go ahead and find out what our focus, that's what we've been trying to find all this time. What is our focus? Well, since this is an upside down parabola, we're shifting down our focus from our vertex. So wait, don't leave, because this 1 comma 3 over 2 is a common misconception, okay? We actually have to take the vertex, pull it down for the focus, okay? So we have to adjust this 1 comma 3 over 2 so that instead of subtracting p from k, we add them, okay? So add p and k, and what do we get, folks? What do we get? 1 minus a half is going to give you a half. So our final answer for the focus, if you don't see it right there, it's going to be 1 comma 1 over 2, folks. 1 comma 1 over 2. Thanks for watching. We'll check you out in lecture 5.